Okay, so let's start with the talk. I hope you all had some lunch and some ice cream maybe. So what we want to talk about today is functional libraries for Java. I did actually created this talk when Java 8 was out for about 1 year, because I wanted to see how many libraries out there actually already support to use lambdas. And I also wanted to see if there's some alternatives in using streams. Because if you have used streams, some of the methods are not really intuitive, especially if you use them for the first time, that you have to call collect to do a grouping by, for example, is not really intuitive. So I wanted to have a look if there's some other alternatives out there. And those are among those which I found. And I actually did a quick Twitter survey to not find them all by myself. And a lot of people responded, thankfully. And those are the libraries which we want to have a look at today. So I have 120 slides. Who wants to see 120 slides? No, I don't think you want to see them. So I decided to do some live coding today. You can have a look at the slides later. I will only use some of the slides to give you some introduction now. And yeah, this is me. I'm mainly a Java developer. I'm living in Bremen, which is in Germany, and probably mostly famous for its beer and the town musicians of Bremen. And everything else you can read up later. So functional programming in Java. Some see functional programming as an evolution step, right? So we did go all the way to object-oriented programming, and now we go to functional programming. But, well, I'm not so sure if it really is an evolutional step, right? So we will see that later. You can make up your own mind if you like it or not. Let's do a quick recap of functional programming, which you might have learned somewhere a long time ago. I didn't really remember all the things when I built up the talk, so here it is. The main aspect of functional programming is that functions and values are treated the same. So you can also pass functions around, not only the values, to any other functions. And this also creates higher order functions. So a higher order function either accepts a function as a parameter, or it can return you a new function, which we can do with lambdas, and we will have examples in a minute. Then we have a referential transparency, which means that every call should be able to be replaced by its value. If you think of math random, for example, you cannot replace a math random call by its value, because it will always be different each time you call it, right? So this method or this function wouldn't be referential transparent. So all the functions have to be side effect free, which also means that you're not allowed to throw an exception, because exceptions break the normal control flow and are side effects as well. And a pure function is a function which only calls methods which are referentially transparent, which mostly is only the case if you have immutable data structures. For example, if you call list.remove, then you remove some value of the original data and it's not immutable anymore. So it has, it's not a pure function. And yeah, one of the aspects is closures or lambdas, so that we can pass all these anonymous function blocks around. Some say it's also composition, lifting, and carrying. We will see some examples in a minute. And most of them say it's also functional programming languages should also have filter, map, and reduce. So a pure function, if you think of a list like that with the values A, B, and C, and you call a harmless seeming method, which is called calculate result, you expect still after the call the values to be A, B, and C if you have a pure function, right? Because it's side effect free. So the list you pass in should remain the same. But if you have a calculate result method which does that, like values remove all the values, then it's not a pure function anymore, because it changes the list. So for functional programming languages, you should favor immutable data structures, which most of the functional programming languages only have. So you cannot really modify the list itself. And this is also not a pure function. If you throw an exception, then it's also not a pure function. So with Java 8, we got some functionalish additions. They're not really, Java 8 is not a functional programming language, right? It's still the same programming language we had. We just got some additions to it, which allow us to write programs in a more functional style. So first of all, we have this SAM types for single abstract method types. So everything which has only a single abstract method can be used as a lambda expression, implementing that abstract method. And this is also backwards compatible, right? Because we're still internally, the JVM is still using anonymous classes to actually implement the lambda. So it's still backwards compatible. And this also means that it's still not really a functional programming language, right? We are still passing around objects, but you don't see them anymore. It feels like you're writing real functions. For this, we got some new functional interfaces to actually support us in the process. So a single function which can calculate your result, a predicate which you can use for filtering, a supplier for creating values, and a consumer for just consuming the values and printing them out. And with default methods, we got another nice addition. It now allows us to actually extend interfaces, which was kind of difficult before, right? They would have introduced a sort method like a couple of years ago, and everybody would have to implement the sort method themselves because it was on the interface. It wouldn't have been fun. So with default methods, it was now possible to extend that. And also the method reference, which we see here with a person, get name, right, is really, really nice to read. And let's have a look at what we can do with Java 8 from all this list we had about function programming. So this is a higher order function, which is called the add method. So we are creating a function here. So this is a higher order function because it returns a function. It's a lambda here taking 2 parameters and returning a plus b. So this is a binary operator because it takes 2 parameters. And we can call this function by calling the method apply_as_int with 5 and 6, and it should return 11. With that, we can also have a composition, for example. If we want to add 2 values and then also multiply by 5, we can take the add function and call and then and pass another lambda which multiplies by 5. And then if we pass on the values 2 and 7, we have 2 plus 7 times 5 is 45. So this is composition. And with composition, we can also do some currying. Currying means that we want to fix one of the values of a function. So in this case, we have the multiply binary operator, right? So we need 2 parameters, a and b. And we want to fix one of the parameters to be 5. So we always multiply by 5. And if we call the curry method, which is down here, so this takes our binary function and has the parameter 5, and it returns a new function, which is not a binary function anymore, it's just a single function, so it only needs 1 parameter. And we return that as a new function with always fixing one of the values, the first value in this case, to a, which is in this case 5. So if we call all of this, we have 5 times 6. As a result, 30, I hope. Filter map reduce. I said it's also an important aspect. Filter map reduce is possible on Java 8 streams. So in this example, we create a stream of some ints, and we filter them so that we only have the even values, and then we print them out. With streams, we have 2 types of different methods. One is the intermediate method block, so intermediate operations just modify the values in the stream, like in a pipeline, and you still have a stream, right? The gray one there below is something which we have added in Java 9, drop while and take while. Drop while discards all the values in the stream until a condition is true, and take while is the opposite, so it only takes the values while a condition is true. And then we have the terminal operations. So the terminal operations convert our stream to our final result, which can be a single result. So this is kind of the reduce methods, which can be a single result for max and min operations, for example, and can be a list of values, for example, for the collect method. So the big difference, or the interesting thing about streams is that you can only use them once. So after you've called a terminal operation, the stream cannot be used anymore. So it's not really feasible to pass streams around too much, because you never know if it's already invalid because a terminal method has been called. So if we do have a look at our list, so passing functions and values around is kind of sufficient in Java 8. Like I said, it's not really passing functions around, it's still kind of objects, but it's good enough. We can build higher order functions, that's not a problem. Referential transparency is not really fulfilled unless we use another library, which we'll see later, but with Java 8, with only Java 8, it's kind of difficult, because even if you make your list unmodifiable, there's still the methods on it, like add and remove, and then you get some nasty exceptions, so it's still not referentially transparent. Same for pure functions. We have lambdas. We can do composition, lifting, and currying. We have an example of lifting later. And filter map and reduce is fulfilled with streams. So it's kind of okay to do functional programming in Java, even though it's not a functional programming language. So before we start with some of the live demos with the libraries I'm going to show you, there's other JVM languages which really support functional programming style, right? They still run on the Java virtual machine. Like, for example, you can have an Haskell implementation running on the Java virtual machine. And Java is really conservative in adding new API. There were a lot of people complaining that there's not directly a grouping by operation on the stream, for example. But they said, no, we only want to add the methods which are really essential for getting started. And then we might add new API later, like we have seen with Java 9. They added the drop while and take while. And they're constantly seeing what are developers doing, what are the main things they really need, and might add the API later. And please, if you like one of the libraries, please still test drive them with your use case, because the performance might actually degrade. It might really look nice from the API point of view, but if you're using immutable data structures and you always have to create copies and so on, it might decrease your performance. So my first example will be, we're going to have a look how the Java 8 Streams API is going to feel like. And my example is, usually what we do in our office is when there's more than one person having a birthday on the same day, we're going to organize a breakfast together for us. So they're going to invite all the people by email and saying, okay, we are like 3 persons having a birthday on the same day, so we brought some rolls and meat and cheese and so on, so let's have some breakfast together. So let's see how we can actually remind people of organizing a birthday breakfast by going through the list of employees and sending them an email if they have a birthday on the same day. So with Java 8, what we do here is having an employee register with all the persons working in the company, and we are going to create a stream, and we are only interested in all the persons having the birthday in the current months. So we're going to filter out only them. And then we can group them together. And this is what I always want to do, right? I want to group by, but there's no group by, so I have to say collect. And then I can use grouping by. And what we want to have is only the month and day of the birthday, because the year doesn't really make sense in this case. Person get birthday. Right. So because collect is a terminal operation, I don't have a stream anymore. So with filter I still have a stream, with collect I don't have a stream anymore, so I have an intermediate map in this case. A map which is from a key from the birthday to a list of all employees with the same birthday. And if I want to continue, I have to create a new stream over the entry set, and I want to filter out all the entries which have actually more than one employee with the same birthday. So entry get value size is bigger than 1. And then I want to sort them. Sorted, I want to sort them by the birthday. And what we do here is sorting by a comparator. So I have to call comparing first. And then I can pass in a function which will be the entry get the key, so I sort by the birthday. And then we can call for each, and for each of the entries send an email with the value, so the birthday, and then all the employees with the same birthday. So all of them get the same email, like organize some breakfast together. I'm gonna execute that, and you can see down here, this is the result which we get. So we have a big list of employees, and they all get the same email, like person 68, 129, 207. So this is register information, and please organize a birthday together, right? So this is how we can do it in Java 8. So from my point of view, this kind of feels like, right, lambda. You can think a bit of lambada, but if you have this burning bar there, you might burn yourself very easily. So it's not really nice that we have this terminal operation in between, and it's really hard to think of the right things which you have to do. So there's jOOL. It's not really the logo, it's just a pronunciation help, the jOOL. And with jOOL, there is some additions to the Java 8 streams. So it's actually implementing stream. It's also implementing iterable. So if you like to pass iterables around, which a stream doesn't implement, you might want to have a look at that. The sequence or seq class already says it. It's always sequential and ordered, so parallel has no effect. And what I really like about it, so jOOL is one of the siblings of JUnit, and JUnit is a SQL mapping library. So it has SQL-like collectors in Java. So if you like SQL stuff, then you might want to have a look at that. It also has functions with up to 16 parameters, not only up to 2 parameters, which we have in Java 8, and tuples are the same. So if you have like a tuple of 4 values and you want to reduce it to 1 value, you would have to need a class in Java 8, but with jOOL you can directly do it. Have a tuple with 4 values, 1, 2, 3, 4, and reduce them to a single value. So, for example, multiply all the values. So let's have a look how we can actually solve our little birthday example with jOOL. So with jOOL, like I said, we need a sequence. We can get a sequence with sequence, and we pass in still the Java util list of persons. And then we, first of all, we start with the same, with the filter operation, which you can see is still implemented from the stream with the person get birthday, get months is in the current months. And then we start differently because we directly have the grouped operation. We don't have to call the collect, so it's kind of more intuitive. And we want to group it still by the same thing, month, day, from person get birthday. And then we pass in 2 lists because we want to have a list of all these things, which I'll show you in a minute. So what we have now is, you can't probably see it in the back, but the front should be able to see it. So we now have a tuple 2. So we don't have a map entry. A map entry is kind of a tuple 2 as well, right? It has 2 values. So we have a tuple of the month, day again, and the list. But we still have a sequence, so we are still in a stream. But this is one thing you have to watch out when using this other libraries. While Java 8 is very clear about if it's an intermediate or terminal operation, it's not really clear in this case. Grouped is still kind of a terminal operation. You can go on after that, but it will consume all the values in the stream. So it's not continuing with the normal pipeline. It will consume all the values in the stream up until this point and gives you back a new sequence. So we then do the same, like we filter it on the tuple. We call the value 2 of the tuple. Size is bigger than 1. The sorted is different again. It's not the sorted we had to use here, which takes a comparator, but we can use a function directly. So we can say tuple 2 v1. We want to sort by that. So by the birthday. And then we say for each again and send out the email of the tuple, send mail, tuple v1 and tuple v2, right? So this gives you the same result. I'm not going to show you that, but we have some improvements here, like grouped and sorted, which takes the function directly. But another very, very nice thing which jOOL can do for you is, like I said, it's the brother of JUnit with all this SQL-like stuff. So whom of you has ever used a window function in SQL? Yeah, some people in the back and some in the front. All right, so you know how to do it. But to the rest, I will explain what a window function is. In this example, you can see my bank account, right? I opened the bank account in September last year with a balance of 0. And then I directly withdraw some money of minus 20 euros. So I can still calculate that. The balance is minus 20. But afterwards, I'm really bad with math, right? So I can't really calculate the rest of the values. So we want to calculate all the question marks. So we want to have a result per line, right? If you have a normal reduce operation, you only can get the balance of the current date. But we want to have the running balance for each of the days. So we initialize the jOOL library with a tuple2, and we pass in the dates, and we pass in the values for each of them. So we initialize it with the table, and we just create a stream or a sequence of that, and then we call the window function. So what the window function is doing, it's comparing all the keys here, or the value 1, which is all the dates. It's comparing by all the dates, so it sorts them first. And then it creates windows of all the previous dates of each of the dates. So for the 27th, all the previous dates would be the 20th and the 11th. And it goes up to the value itself, to 0. What we can also pass in here is like only -1, so we only have one previous date as a window. So how will the windows look like if we have this as an input? The first window would be just the date itself with its value. For the second date, we have the date itself, the 20th, and its previous date. And for the last, we have just all the days. So these are called the windows. And now we can do some calculations over the windows. So we have these windows here after calling the window method, and then we want to map them. We want to add the third column, right? So we get from tuple2 to tuple3 by calling the concat method. And what so we have to calculate the third value, and the third value will be the sum over all the value 2, so all the withdrawals or the deposits on my bank account, and we just create the sum of that, and then we concat it. So how does it look like? So with our first window, we just have the value itself, minus 20, that's easy. For the second window, we have the values minus 20 and 100, and for the third window, we have minus 20 plus 100 minus 5 is 75. So this is our result with jOOL then. So we get all the lines here nicely out as a tuple3, and we can fill in our table, right? So this is a very nice addition to have window functions in Java 8 or 9. So Vavr. Vavr is, maybe most of you know it, was previously called Javaslang. So never have Java in any of the library names, please, because they're going to sue you from Oracle, or you have to pay. And so with Vavr, we have immutable and persistent collections. They are still called list, set, and map, like in Java 8. You just have to change the imports to be able to use Vavr. And those are all immutable, so we only have pure functions on the collections. We also have tuples and functions with more values, and it really enforces you to use the Vavr data structures. So because the stream-like methods like filter and map and so on will be directly available on the collection itself. We don't have a stream anymore, so we don't extend stream. We are only working in Vavr, but there's converters to get to Java 8 again. So with Vavr, because it's a functional programming language, it directly implements some of the features of functional programming. Sorry, not a functional programming language, a functional library. And so to get from a function 2, like we have seen earlier, I coded the curry function myself, and Vavr is directly included. So if you want to always add 2 as a value, you can call the curried method and fix one of the values to 2. So you only have a function 1. And if you pass in 4 as a parameter, then you get back 4 plus 2 is 6. You also have a lifting, like I said previously. So what does lifting mean? We have partial functions. A partial function is a function which is only defined for some of the input values. So if you have a divide operation, for example, it's not defined for dividing through 0, because dividing through 0 won't give you back a result because it's not allowed, so it will give you back an arithmetic exception. So this is only a partial function because it's not defined for all the input values. And to make it a total function, we can call the lift method. So what the lift method does, function2 lift, and it converts the integer return value of the function to an option. So in Java 8 it's optional, in Vavr it's option. And now we have a totally defined function. So if we call 5 divided by 0, it now gives us back none. It doesn't throw an exception, so it's kind of defined. And with waiver, what we can also do is memoization, which is very nice because, like I said previously, like the math random function is not a pure function because it cannot be replaced by its value. So you have to call memoization on that. So if you take this function and call memoize on that, you still have the same function, which doesn't take any parameters, so it's a function 0. And if you call memo on the memo object, if you call apply, you get back a value on the first call, and for all subsequent calls it will be the same value. So your first is equal to second. Now let's see some live coding with Vavr. So if you go back to our birthday example, I'm not going to code that, it's going to bore you. So with Vavr, we kind of have the same functionality as with jOOL. We have a filter and we have grouping by directly. We can omit the sort here because grouping by directly sorts by the key of the operation. But other than that, it's mainly the same. So suppose we want to do some pattern matching operation. With Java, we have to use a switch. So for each of integer values, we want to give back a string which calls out the number. So if we switch over the num and we say, in the case of 1, we want to return 1, then we have to assign it to a variable, right? So we have to create a variable called result here. It should have been a global variable. Let's do the next step first. So in the case of 2, result is equal to 2. Now Eclipse should be smart enough. Create a local variable. And then in the default case, we just say we have no idea what the value is. We can't parse that. And so what did I do wrong here, right? I already forgot the break statements, so otherwise it would be a fall through and would only return a question mark for all of them. And I also have to assign it to a value outside of the switch block, which is kind of not really nice, right? So if we do a sys out here, it should print us 2, right? That works. So with Vavr, what you can do is do real pattern matching. So into the match method, we pass in the value. And then we give it some cases here. So we have a case, and then we just match the values. The syntax is kind of weird, but it works. So $value2 is 2, and in the other case, if I don't know what to do, I can just leave it empty and have the question mark. And the nice thing is I can directly assign it to a value here, match result. And this is really more concise than the switch case up here. And if I print it out, it should hopefully return us the same result. 2 and 2. But this is still kind of boring, right? So what we really want to do is have different objects and do something with the objects based on their type. So I first go with an integer here. I'm gonna match that off, and so we have now different cases based on the type of the input object. So we say case instance of integer class, and now we can pass in a lambda, and it will give us already the correct type. So in this case, for I, it's an integer value I get, so I can directly apply 1 to it. And in the next case, I want to do the same, adding 1 to a local date instance, so we can get the next day. And for the value, for the date value, I can directly get it back as a correct instance, so I can directly call plus days here, no casting involved or something like that. So this is kind of nice. I get back an object plus 1, and I directly give it out here. And for our first example, we should get 2 back, right? And if we change it to a local date of now, we should get back the 9th, which is tomorrow. So this works as well. So let's quickly have a look at some unit testing. JUnit 5 is out since a couple of months. So JUnit 5 was founded as JUnit lambda, so they wanted to be able to use lambda expressions in JUnit for testing. There's another nice couple of methods, like in assertions, you can use them as well. But a nice thing is like expected exceptions. So there was support for expected exceptions in JUnit 4 only if you wanted to see if the exception is thrown. But if you wanted to test if there's a certain message in the exception, you couldn't really do that really nicely. You had to write a try-catch block. So with JUnit lambda, you can just use the method expectThrows, pass in the class of the exception you want to have, and then pass in a block which wraps the code you want to execute. And then you get back the exception, if it has happened, or you don't get it back, right? And then you can call assert equals with the eGet message and test if the message is correct. So this is one of the nice things. And what if you want to test if all Fibonacci numbers over 2 are odd, right? What you would do is create a test in JUnit 4, test Fibonacci number of 1. Test is odd, Fibonacci, pass in the value 1. For number 2, do the same. Test is odd, Fibonacci of 2. Test is odd, Fibonacci of 3. Test is odd, Fibonacci of 20, right? This is not really nice to write, so we don't want to do that. With JUnit 5, we can do it differently, like this is my test case, right? So right now it only tests for Fibonacci 1 and 2, and we want to cover the rest of the test. We just create a method called testAll, and we create an int stream of our input values from 1 to 20. And then we map it to an object, so we get our number here, and we want to calculate the Fibonacci number, and we create a dynamic test case out of that. We can give the test case a name here, so Fibonacci of n, and then we pass in the block again, which we want to be executed, which is the same like over here, test is odd, and we pass in the value we got here, which is n. It doesn't look right. So, misplaced constructors, I did something wrong here. There should be another base, right. So this is what we have here. So this is how we can actually create dynamic tests. That should be like that. So that works like that. So, and then we return that. And what it returns is a stream of dynamic test objects, which we just created. And we don't annotate it with a test, but with a test factory. If we execute it now, it will execute with all the Fibonacci numbers here, right? From 1 to 20. If we want to quickly change it to 30, we can just do that. And now we have it from 1 to 30. So this is one of the additions, creating dynamic test cases for various input parameters. Now we go to reactive libraries. So what we are used to do is really sequential processing of stuff, right? And if we wanted to execute something in the background from JavaScript, we are used to having callbacks. So that wasn't really possible in a nice way with Java 8. Before Java 8, but with Java 8, we now, for example, got the completable future, so we can read in a list in a background, from, for example, from a file, and get back a list of string wrapped in a completable future. So completable future will execute in the background, and we can register some callbacks, and they will be called when the result is ready, right? So we can call, for example, then apply. So this will be applied when the list is completed. So we just print out that we read in the list. In case of an exception, we just give out the error message and then we all print it out. But I still think it's kind of hard to use. So the API is not really easy to understand. An alternative to that is JDeferred, which is like JavaScript's or jQuery's deferred objects. So with a deferred object, I can do kind of the same. So I register some different callbacks, but the names are kind of easier to remember. So I have different callbacks. When the calculation is done, I have a callback. When it fails, I can get the exception back. I have a callback for progress, so for reporting, for example, the percentage of reading in a file. And I have an always as well. And let's see how it looks like. So if I read in one of the files with JDeferred, one of the files I have on my hard drive, I get back a promise of the async reading operation, and I can just register the callbacks. In the first case, I get back the byte array of the file, and I just printed out how many bytes we did read in. Bytes b plus length. And we can also report some progress here, so we get a percentage back. This out percent plus the percentage over here. And if we execute that, we first have to wait for the promise to be finished, because otherwise my main method will exit. So we call wait safely and see how that goes. Go to the console. Right, so it prints the percentages over here and the byte. So this is kind of nicer as a complete to the future, I think. Now let's see how much time we got left. What time is it now? Oh, so still some minutes left, so they finished a little early. So one of the next things we want to have a look at is RxJava, which is also a reactive library. They are well known for their nice little marble diagrams describing the operations in their Java doc. So if you ever wanted to know how the flat map operation works, maybe these marble diagrams help you. And with RxJava, what it's really good in doing is some timed operations. So usually you get back an observable, and observable also has the stream-like methods. You can think of an observable like a stream. But you can get a stream from a various kind of different libraries which can feed in you the stream. Like, for example, from a socket or something like that, right? So there's different connectors for that. I just create a very simple observable here, and with 3 items, which I repeat 20 times. So with an observable, the good thing about it is that I can call subscribe multiple times on it. So it's not like a stream, which is just a finish after I use it for the first time. I can call subscribe multiple times. It will then print, in this case, it will print 40 values in my console. But this is still very boring. So what we do now is we create an observable, and we want to have some timing in there. So we create an observable, how's it called, interval of each second we want to have 1 value. So this is our time emitter. And if we call subscribe on the time emitter, subscribe, and print it out, we get just the seconds back. Each second, oops, yeah, I have to wait on it for it to be finished. Time emitter. And then we get 1 value each second. So 0, 1, 2, and so on. Right, this is still very boring. So what we want to do is we want to combine the time emitter with our items. So we call the zip method. Zip methods are passing in so they take one from the one observable and one from the other observable. This is what I get. And then I have to combine them myself in this lambda expression. So I get x and epsilon, and I only want to return one of our items. So I get back a new observable in that case, timed item emitter. And on the timed item emitter, I can do like previously, just have the subscribe method, and then I should get back one of our items every second. So this is what it does now, right? One of our items every second. But we can also do different things on that, like, for example, having windows again, the windows are kind of different, like the window function in jOOL. So we create windows, for example, of a fixed number of values or of 10 seconds in this example. And with this window, I can call subscribe again. I get a group of all the values which happened within the last 10 seconds. To make it more visible, I say 10 seconds and have all the items printed out as a list, and can call subscribe again, like previously, and print those out. So if we run it together, like you can see, you can chain all kinds of observables and subscribe to them as often as you want. So they're just going to print out over here, and after 10 seconds we get a bigger group, right, of all the past values. So it's very good in handling this timing things, and also very good in handling exceptions and back pressure. And where's the slides? There's the slides. And with Java 9 there is a Flow API added. So Flow API is going to abstract over all the reactive APIs which we have out there, like RxJava and akka streams and so on. I don't think there's any implementations out there right now, but there are going to be implementations of all those APIs, so you have a common interface of that. And one last example is Vert.x, which you can use to create all kinds of reactive applications on the JVM. Like you can see in the list, it has a lot of connectors to different kinds of libraries. We want to build a very, very simple web server in our example. So in this example, we create a web server, Vert.x, create a HTTP server, and we register a request handler, which is a callback again. So for every request, we just write a response, hello world, and we start this web server on port 8080 and just print out when the web server is ready. So there we get back the URL, and somewhere I have my web browser. And if we go to 8080, then it prints out hello world. Very simple. But what we really want to do is build a more sophisticated web server. So at work, I used it, for example, we had some of our customers was supplying a really, really old interface. They kind of did write me back JSON responses for different routes for different paths on the server. So what we can do with the router, we create a router here. And on the router, we can call route, and given the path, for example, for the city name Bremen, I want to get back the country. And we can call the handle method, we get back a context, and for the context we pass in a lambda. On the context we have the response, and with the response we want to write back the name of the country, which is Germany in this case. And what we do here is now we create our HTTP server, and instead of directly handling the responses, we give it in the router to actually handle the responses. If we execute that, then if we go to Bremen in this case, then we get back, hopefully, if I didn't do anything wrong. Yeah, I changed the port to 81, and then we get back Germany, right? So this is very, very simple web server stuff, which is perfectly fine for testing, but you can all build kinds of sophisticated applications with that. So as a summary, we have seen a lot of different libraries. Those are actually all the libraries which are back in the slides, which you can find in the slides. And if you want to actually have some more libraries, those are listed here, but I didn't do any examples for those. And for Java 10, or maybe later, but I think it's currently scheduled for Java 10. Do you know, Sander? It's not scheduled for Java 10, okay. But for some later version, we will probably have a real pattern matching in Java as well. So there's some nice things coming. As you may know, that the Java 10 release is due in March next year.